Hi everyone! In this video, we will identify the null and alternative hypotheses for a population proportion. Dr. Smith, the Dean of Medical College, is investigating whether the pass rate of the medical licensing exam has improved compared to previous years. The college has implemented new teaching methods and wants to see if these have had a positive effect on the students' performance. Dr. Smith looks at the class of 2015, where the pass rate was 75%. She then takes a random sample of 985 students from the class of 2023 and finds that 788 students passed the licensing exam. Confirm all conditions for a hypothesis test are met. We have three conditions to meet for a hypothesis test. The first one is to ensure that we are working with a binomial model, which means that we have two independent outcomes, either a success or a failure. In this case, we're looking for whether the pass rate has improved or not, which means we are working with binomial. We're looking for an improved or not improved pass rate. The second stipulation that we need to meet is that the information has been randomly selected. So let's look at our data. It says she takes a random sample of 985 students. So yes, the data has been gathered randomly. Now for our third condition, we need to ensure the number of trials times the proportion of successes is greater than or equal to 5, and that the number of trials times the proportion of failures is also greater than 5. So let's go look at our information. We have a population proportion pass rate of 75% that was given to us. So we know that P is 75% or 0.75. And Q is the opposite of that, or 1 minus the 0.75, which gives us 0.25. If you need to put a little reminder here, this is 1 minus the proportion of successes. Now we need to find the number of trials. This is N, and we look back and it shows us that she got a random sample of 985 students. So we know that N equals 985. So now we can multiply those together to ensure that both of those conditions are met. N times P, which gives us 985 times 0.75, and N times Q, which will be the same 985, but in this case times 0.25. Using our calculator, 985 times 0.75 is 738.75, and 985 times 0.25 in my calculator is 246.25. Both of these are greater than or equal to 5, which means that both of those conditions are met. This means that we have confirmed all three conditions have been met. Our first one is that we did indeed have a binomial model, and so this has been met. Number 2 is that the data has been randomly selected, and that number 3, that N times P and N times Q are both greater than 5. So now we can identify the null and alternative hypotheses. The null hypothesis must have an equal sign in it, and the alternative hypothesis will have a less than or greater than sign or a not equal to sign. And since we are working with population proportion, we know that our null and alternative hypotheses will have a P, and the null hypothesis will be an equal sign. And we were told that the class of 2015 had a pass rate of 0.75. This is our population proportion that we're looking for. So it equals 0.75 in the null hypothesis. And the alternative hypothesis, the dean is investigating whether the pass rate of the exam has improved, which means it will be greater than 0.75. So now we've met all the conditions for our hypothesis test and identified both the null and alternative hypotheses, so we're all done.